All right, so today what we're going to do is we're going to take a look at the random number generator that you're going to use for this assessment. And we're also going to look at a little introduction to to simulations, the very first part of our project, our paper, the first part of what you're going to be doing in this paper. So, first thing I want to do is just go to look at the random number generator. So let's start there. Okay, so the random number generator that I want you to use is simply at random.org/integers. Make sure you put the /integers on there. Otherwise, you're not going to be getting the right site. So let's just take a look at it. Now, this isn't going to make complete sense to you right now, but it will in a moment when we look at how you're going to use these. So remember last time we talked about doing a simulation. We talked about rolling a die, yeah? And so we had numbers 1 through 6 that we could use. But when you're dealing with larger experiments, you might have hundreds of choices. And each choice needs to be assigned a number based on its probability. So let's say that we had 100 different choices. So we could generate 100 different random integers. And you're just going to put in how many you want. Some of them, and you're going to see today how you decide how many you want. And then you're going to put them in the values. And you don't have to worry about 5 columns or how you do that. That's no big deal. All right? Then you just select the numbers, and it's going to give you the random numbers. Now, this is a much bigger random number set than you're going to use for any of your experiments. But you see that it gives you all of the random numbers. Yes? And each one of those is going to correspond to a different item in your simulation. So, couldn't be easier. We're going to use this a lot. Now, in the book, they're going to want you to use a calculator. This is much easier if you'll use the random number generator than a calculator. A calculator can give you one number at a time. And if you need 30 numbers, that's not fun, right? But this will give you a lot of numbers, and you can just go through the list very quickly. All right. So, let's now go to the book and look at how you're going to use this and what you'll be doing with these. All right. Okay, so let's talk about the simulation process. So, step 1. Here are some things that you need to know in order to make this work. You need to know all the possible outcomes are, what they are. So every possible outcome. So say, for example, you could have a cat, a dog, a cow, or a horse. That's how many different outcomes? 4, right? So you have to know all the different outcomes. And you're going to list every possible outcome. You need to know the probability of each outcome. This is generally given to you, but there are going to be a few that are so easy that you could find the probability of them. But then most of the time, they're going to give them. And check this one. That's very important. You must check that all of the probabilities add to 1. Because remember that all of the probabilities added together have to equal 100% or 1. Right? If they don't, then you're going to be missing some pieces and your project won't work. In your paper, after you've decided all of this, you will decide which device you'll use. And you're going to see an example of how this is written up when we look at it. You will literally have to tell me, I will use my computer and go to random.org/integers, and you're going to have to describe that process. Okay? All right? Well, good. Then you'll know what you're doing. All right. Then you're going to describe how you're going to use your device. Guys, shh. And then you're going to create the following table. I need for you to go to Microsoft Word. I want you to create a table that looks like this. We're going to practice using it. I want to see this table, literally this table. You can color it any colors you want to or use no color you want to, but it has to have a list. The first row is always every possible outcome. Now you don't have to create it now. I just want you to have it created for your paper is what I mean. Yeah, I would rather you not have your computers open now, please. Then the probability of each outcome. Each outcome. So if you went back to that example, an outcome is getting a dog. Getting a cat is an outcome. Getting a horse, getting a cow. Each one of those things that are possible is an outcome. And then you're going to assign random numbers to them. Now, you're not going to put random numbers from dice, etc. You're going to put random numbers and then use whatever device you are going to do. You don't have to tell me what you'd use there because you've already described it above that. So let's just look at an example of what this looks like. A soft drink promotion involves collecting bottle caps which have one of the following letters printed on the inside, SNAP. Amy bought a bottle each day from the school canteen. The soft drink company has distributed these caps with the following probabilities for each letter. So she's going to be collecting these letters to win a prize, right? And so she's got to get all 4 letters and spell the word snap in order to win the prize. Make sense? Okay. And so if you look, first thing they do is list every possibility. So this is every possible outcome. You could get an S, you could get an N, you could get an A, or you could get a P. And the company has provided the probabilities for these. So the probability of an S is 0.4, so that's 4 tenths, right? 4 tenths, which is the same thing as 4 out of 10. Keep that in mind in a minute. All right. For N, that's 3 tenths, so 3 out of 10. A is 2 tenths, and P is 1 tenth, so 1 out of 10. Okay? All right. So notice the next thing they did was they added up all the probabilities to make sure they equal what number? 1. Yes. Then, in this case, the device they're going to use is a pack of playing cards. You have to label the device you're going to use. And then you have to say how you're going to use it. So they've described that. They're going to draw cards from a 52 card deck, replacing each card after it has been drawn. If you use a device like cards or something where you're pulling something out, you have to make sure that you say that you're putting it back in. Otherwise, you change the probabilities. Because if you don't put it back in, you can't draw that same card again. Now, we're going to use random number generators so the numbers won't be eliminated. But if you do something like this, I'll record only the aces and the numbers 2 through 10. And that goes back to these decimals. 4 out of what? 10. 2 out of what? 10. 1 out of what? 10. So 10 was the number of cards that I needed to represent every possible event, right? So what if it was 0.35? That's 35 what? Hundreds. So I would need 100, guys. So I would need 100 numbers in that case, right? So the denominator of the fraction will tell you how many numbers you need. Okay? So just give the name of it. It'll tell you what the number you need. All right? They're only going to record aces and the numbers from 2 through 10. So they're going to ignore the picture cards. And remember the probability of getting each of the aces and numbers. If there's only one of each of them, that's 1 out of 10, right? Because you can get one number. If you pull one thing at a time, you can get one of those 10 things to happen. So now look at the next thing. Since the probability of S is 4 out of the 10, the first 4 cards are assigned to S. So they assign the ace, the 2, and the 3, and the 4. So if you reach in the deck and you pull a 4, that stands for what letter? S, right? Reach in the deck and pull a 2. That stands for what letter? S. So then the N is 3 out of 10. So the next 3 numbers are assigned to N. So 5, 6, and 7. A is 2 out of 10. So the next 2. And P is only 1 out of the 10. So the 10 is the only one that represents the P. Yes? Okay. Now, it is critical that you understand where these numbers come from. This is probably the hardest part of this paper. Telling you, you're going to love this one. Okay? Now, so here's another one. This one, they're going to use their calculator, and they're going to use their calculator with this formula. You don't have to worry about this formula. You're not going to use your calculator. And they're going to ignore the digits after the decimals, and then you still see that 1, 2, 3, 4, 5, 6, 7, 8, and 9, and 10. Right? So let's look at an example. Another example. So here's a farmer has a flock of sheep, and here are the probabilities. Notice that this time it's 0.49. So that's 49 out of 100, exactly. So we're going to have 100 random numbers in order to make this one work. Do you see how the process works? Now, what if I was given my probability as a fraction? 1/2, 2/3, 3/4. What could I do to turn them into decimals, right? And then I could have 1 out of 100, 3 out of 100, whatever, right? If you turn the fractions into decimals, then you can always read it that way. Okay? So if they are given to you in fractions, and they often will be. So here, if you see, probability for the number 1 for 1 lamb is 49 out of 100. So the first 49 numbers are dedicated to 1 lamb. 2 lambs gets the next 45 numbers. 3 lambs, it's only 6 out of 10, so that gives you the rest of them. But we knew that there would be 100 numbers because there were 2 decimal places, which is the hundreds place. Yes? Okay? So what we're going to do first is we're going to fill in this questionnaire. So somebody who knows nothing about the topic guesses multiple choice questions in a 14-question test where there are 6 possibilities for each question. Only 1 answer for each question is correct. You're interested in how many questions they're likely to answer correctly and the probability that this person will get 5 or more correct answers. Okay? So, every answer is equally likely to be chosen. Do you agree? If you just have 6 problems, you're not more likely to choose 1, right? So you have your book. What does step 1 say I need to do?
Page 19.
Okay. So look back into the directions on the page before that and tell me, what does step 1 say I need to do? I need to list. Every possible outcome. There you go. Okay. So my possible outcomes are, come on guys. I could choose, sorry. Should have done the whole thing blue.
Can I go to the bathroom?
I could choose answer 1, 2, 3, 4, 5, or 6. Yes, those are your outcomes, right? Now, those are your outcomes, but think about if you're answering a question correctly, okay? So there's 6 different things, but out of those 6 different things, I'm going to see if it's either right or what?
Wrong.
Right or wrong. So out of those questions, what I'm really interested in, was it right or the wrong answer? Because are you really concerned about what those answers are, or are you concerned whether you got them right or not? Exactly. You don't care what the answers are. So here is what we're going to be measuring. And if you go back down here, you see they've already listed the outcomes for you, right? Okay? Now, step 2. What's step 2? What device we're going to use? A probability. Well, we're either going to get right or wrong, so what do you want to do? Well, you want them right, but I mean, it's just saying, what kind of device you want to use? You could use a dice, or you could use a coin. Heads equals correct. Well, I'll use correct. Tails equals incorrect. Right? That would be an easy one to use on this one, yeah? No?
What does this say?
Why not?
Because if you use a coin, it's got a 50% probability, and if you use a dice, then it's 1 out of 6.
There you go. Do you see the reasoning here? How many questions were there? So if you use a coin, you can only get right or wrong. But the probability that you're going to get it wrong is not going to be 1/2 if you have 6 questions, if you have 6 to choose from, right? What's the probability that you're going to get it right? 1 out of 6. So be careful. Even though there are only 2 of these, there are actually 6 different numbers, right, that will give you the right answer. Okay? Okay. So again, we chose a die. 1 correct answer out of 6, so that's just the number 1. 5 incorrect answers, so that's the other 5 numbers.